In this video, we're going to be taking a look at the Dart 2.17 release, and I'm going to be introducing some of the new features added to the Dart 2.17. So we're going to be taking a look at things like enum members, which allows us to add fields to our enums and also add member functions. And we're also going to be taking a look at super initializer, which helps us reduce duplication of efforts and rewriting the same kind of code. We're going to take a look at that. And we're also going to take a look at some of the things that has been improved in Dart. For example, we got improvements on tools, links 2.0. We also have some documentation improvements and some API sample code added to a lot of the tools and a lot of the documentation. And we also got this thing here called the bug secure socket. So we're not gonna be talking in depth about this. We're only gonna be taking a look at some of the things added to the language at the language level. We also got some platform improvements here. For example, we've got new architecture. There is V architecture, so they're adding some support for this new instruction set. And there is also something interesting here, which is executable signing. So this is particularly useful for Windows and Mac OS users, which those platforms sometimes, I think the Windows Store and the Apple Store require that your executable is signed before you can actually release it. So this could be useful for those people developing for those platforms. So the first thing I'm gonna say, so what we're gonna be taking a look at is the new features introduced in the Dart 2.17 release. So the first thing I want to take a look at is enhanced enums. So what are enhanced enums? Well, enums in general are just things like this. So you can find an enum here, which is just something. So if I take a look at this enum, which is showing a gender, you can see that here we have male, we have female. So this is a typical enum that we had that we have in Dart, and this is perfectly legal. This is a perfect way to define an enum. So it's just an enumeration of values, right? So of course you could add as much as you want here. I just this is just a tool that came to my head, and I wanted to add that. So sometimes you might want to add like functions to this enum. You want to make the method of functions do something, and the way to do it before Dart 2.17 is you could add extension functions. So you make extension functions, and then you can use that to kind of attach that to the gender. So you could use, for example, extension on gender, and then you specify the functions you wanted to add to this enum. So in Dart 2.17 you don't have to do that anymore, because functions are now directly supported inside of enums. And not just that, we now also have the ability to have fields, which of course fields have to be final, but you could have final fields inside of an enum, and this is really cool. So if you want to embed some properties inside of the enum, say for example you wanted to have, I just added a score here, but I could add more things, like for example some genetic features of maybe male and female or whatever, and then I'm going to initialize this inside of the constructor. So the way you call this, so as you can see, this is a const constructor, and the way I do this is in the male, you can see I initialize this in the constructor and I initialize it. So this is how you're going to work with enums with values like that. And as you can see, this is an example of a function or a method inside of the enum. And as you can see, I could also override to string, which controls how the enum is printed to standard out and whatever. So as a test, you can see that we have a test. I'm creating a gender, it says it's male here, and I'm printing the name of the gender, which should print male, and score is score. So here I have 1 for the score, so this is what I should get. And as you can see, I'm calling a function to verify that this actually works. And if I run this program, you're gonna see that you're gonna get the results you expect. So gender is male and score is 1, is male, true. So that works. That's all you need to know about enhanced enums. The next thing we want to take a look at is super initializers. So the way super initializers work, let's go back to some sample code here, is that if you if you have a class called animal, for example, and this is the superclass, all right? So we've got a subclass called dog. So the way it works is this animal class has two final fields, and that has to be initialized in the constructor. So if you're a subclass, you have to kind of initialize. I'm just gonna uncomment this for a minute and comment this out. So we have a dog that extends animal, so it has to find a way to actually initialize the values of the superclass. And the way to do that is to create a constructor for dog and specify values like this. Of course, we could change this, for example, and just take a name because we know how dog sounds. So this is just going to be something like oof, for example. But just for the sake of example, say we want to pass this to the color and have them specify how a dog is supposed to sound. So here, if you want to pass or forward this argument to the constructor prior to Dart 2.17, what you gotta do is first of all declare the arguments, and then you pass it to the superclass. All right, so you use this colon and then you pass it to the superclass in the argument initializer. And so this is perfectly fine, but there is a better way to do this now in Dart 2.17, where you could now extend, once you extend your animal class, you can see that instead of having to declare the variables first or declare the arguments first, I could just say that I want the superclass name here, the superclass sound here, and I'm good. Like, that's pretty much everything I need to do. I don't have to, and this reduces code bloat a lot because you don't have to duplicate the same thing over and over again, and you don't have to make mistakes, forgetting to initialize things, or because I can make the mistake here where if I wanted to, I can mix this up and say that this is the sound and this is the name. Okay, and of course that's a silly mistake to make, but it's possible. And so, but with this, you don't actually make that mistake because you only specify the name and then you specify the sound, and it doesn't matter the order with which you do it. So even if you do it this way, you're still initializing both values at the end of the day. I hope that makes sense. So that is all you need to know about super initializers. It's pretty easy to do, it's pretty easy to use, and I feel like it will help you write proper, more readable code in Dart. So that is all to know about super initializers. And the next thing we can take a look at is named arguments. So what are named arguments? Let's take a look at some code again. So named arguments are things like this. So when you have a function or a constructor or whatever, and you have an argument that should be named. So I'm going to show you guys what a function that has a named argument looks like. So this is a method, and I want to add arguments. So the way the argument works is, so this is a named argument. So if I want to call this function, for example, I have to specify a name, so value, and then maybe 10 or null or whatever. So that's what a named argument looks like. And so what has improved in named arguments inside of Dart? So before, what you can do when you're working with named argument is, if you look at the signature of this function for a minute, you're gonna see that we have the length, we have the generator, which is a function that you can pass inside of here, and then we have this named argument growable, which is equal to true. All right, so the way it works, the way named arguments worked in Dart is that you have to pass the value, you have to pass named arguments after all the positional arguments. So these are the positional arguments, and the named argument has to go to the end. And if you try to take the named argument and put it first, then you're gonna get an error and it's not gonna work. But in Dart 2.17, this isn't an issue. You can put named arguments wherever the hell you want, it doesn't matter. Okay, and I feel like this is really kind of interesting. You can put it here and the compiler is not going to complain. Your code is still going to work as you might expect. And so that is all to know about named arguments. And so the next thing we could take a look at is some of the tool improvements. So let's say there's some improvements to dot links, which I'm not really sure what that is, but you could take a look at that in the release notes. There's documentation improvements, of course, so sample code and everything has been added to documentation. We now got a new FFI template for Flutter, so if you're interested in that, you can take a look at this link to know how you can create Dart-only platform implementations using FFI, for example. Now we have FFI finalizers with NativeFinalizer, which is a really interesting feature. I really love this one. So I'm going to show you guys what that looks like. So the way NativeFinalizers work is, if you've written any native code in Dart before, you're gonna like this. All right. So before, the problem I had with Dart is that if I have a function, if I have a class, a wrapper for a class, and I want that the class to clean up itself when it goes out of scope and it gets garbage collected. So in Dart, this wasn't easy, right? There wasn't a finalizer that we could use. So we resorted to doing some really crazy and nifty tricks to make things work, and it doesn't really always work. And that was my frustration with Dart. And when I heard that we got this native finalizer thing, it really got me excited. And yeah, so the first thing we're going to take a look at is we're going to create a native library that we're going to be using as an example. And for this, I'm going to be using the Zig programming language because why the hell not? So to create this is the Zig file. All I'm just doing here is I'm importing the standard library. I'm creating a simple struct. So extern struct allows you to create a struct that conforms to the CABI. And here I'm creating two functions. Here I'm saying that I want to create a function called load int data, which is going to return a pointer to this struct. So this struct is just a simple struct that has a value of an i32, and here I'm logging something out to make sure that everything works. I want to show the distinction between Zig and Dart to make sure that everything works. So here it says creating data from native code, and then I get myself an allocator. In this case, I'm using the C allocator. So I create the int data type on the heap, and I make sure that if there's any error, I just crash the program. This is a really bad way to code, but hey, what the hell. So, and then I specify the value. So if you pass a value inside of here, this is what gets stored inside of here by default. And then once I store that value, I return the data. So there is another function that says destroy int data. So when you create this value on the heap and return it to Dart, this is going to destroy this value at the end of the day. So you can see deleting data with value in native code. So I'm doing this because I wanted to make sure that we delete whatever we allocate with whatever value. All right. So I take my C allocator again and I use that to destroy this data. And so this function, because I added export in front of it, is going to allow me to use it as a it's going to be visible as a shared library, and it's not going to have all the name mangling thing that Zig does to it. So if you want to compile this code, all you gotta do is, of course, you need your Zig compiler. So you just do Zig build-lib -dynamic lc and native.zig. all right, and you should get yourself this libnative.so file here. So this is the shared object file, and once you have that, we can move back to the NativeFinalizer file. And so here you can see that I'm basically mimicking what I had inside of this extern struct. So if you take a look at this int data, we had an extern struct value i32, which is a 32-bit integer, and as you can see here, I have an int data class, which is the same, I believe it's the same name as this. Yeah. So, and it extends struct. So this is a way to denote that this is actually a struct type. This is an FFI struct, and so int32 is saying, is an annotation that this external value is an 32-bit integer. All right. So this is declaring what a struct looks like inside of native code, and I'm using the representation of it in Dart. So the next thing we could do is to create, of course, a pointer to basically I gotta create the type definitions. All right. So this is what the function looks like this is what the function is going to look like in Dart, and this is what the function looks like in native code. All right, so you can look at different. This is load in data, and this just returns a pointer to in data. And if you want to be sure what I'm talking about, you can see this is returns a pointer to in data here, and it's a function a return that takes an int as a parameter, same as what we have here. All right. So if you look at these two, the native version, you can see that the difference is that I have this int 32. All right, so this is an FFI type, which is what you have to use when you're working with the native side. You can just use the pure Dart type, because it doesn't really work like that. So the destroy int data does the same thing, returns a pointer to in data, and the destroy in data native this time is a native function, of course, that takes this. So you can see void isn't just void here, it's actually a capital void, which is more or less like an object. It's a class inside of the native side of things. So the first thing we do is we create a library, which is using dynamic library.open. I believe if you're working with something like, if you're not using shared libraries, if you're working with say if you're working with static code for maybe iOS or Mac, then you gotta use dynamic library.process, I believe. So there's open and there's process that you can use inside of your program. So to look up a function, you use library.lookup function, and then you specify the native function here, which is what we have for this, and then you also have the Dart equivalent, which is going to return the Dart equivalent. So function pointer to the Dart equivalent, and you specify the name of the function you want to call. You want to look up inside of the shared object, inside of the shared library. And once you do that, then you're going to also do that for the destroy int data. So all of this how FFI works in general, so you should really be familiar with this. And now the next thing which we're going to do is we're going to create a wrapper class for this our int data. So this wrapper is going to be what wraps our int data object and takes care of every little thing. So the way we do it is that I wanted to ignore all of this for a minute, and let's move into the constructor here. So what I do is I take an int value, which is what I'm supposed to take, because this to initialize this int data object I need to take value, an integer as a value. So the next thing I do is inside of the constructor in my initializer list, I initialize the data field. We have a data field here, which is a pointer to an int data, and I call load int data on it. So this load int data function is actually a function pointer, as you can see here, and this is where I looked it up. I looked up this function using the dynamic library object. All right, I hope this makes sense. And then I pass in the value that I get as from the constructor here into that. And now I want you to go back for a minute and let's take a look at this finalizer here. So we have a static late final native finalizer here, and then I'm passing in a function pointer. You can see if I hover over this, you're gonna see that the native finalizer constructor takes in a pointer to a native function of a function that returns nothing, and takes in a pointer to nothing, basically. So what this means is that the finalizer is going to you create a native finalizer that is going to run what this object is garbage collected, and you're gonna attach it to your class. So basically I'm saying that I want to attach, so you can see this comment, this will make that called destroy int data function, because I passed that here. The reason you're seeing this cast is because this needs a pointer to void, but I have a pointer to an int data, so I have to cast that to make sure it works. So Dart is going to call destroy int data when this object is garbage collected, and the way to do that is to call finalizer.attach. Alright, so what this means is that when this object is garbage collected, this is going to attach to that. So as you can see now, the attach function takes a finalizable, which is, so the value I want to finalize is this object here. And remember, you have to implement finalizable to make sure that your object that you can use this native finalizer feature. And so the second value we want to pass in is what should we find, like the data or the value, or it's called a token actually, all right, and it's a pointer to void again. So basically it's the object that we want to delete or finalize when it is time. So I cast again because this is a pointer to an int data, and I don't have an int data, so I just cast it. I just cast it requires a pointer to void, so I just cast that to a pointer to void, and that should work. And of course this is just a simple getter for a value. And so the way to test, so all you need to take away from this wrapper is that it's got a native finalizer here, passing in a pointer to a function that is going to call when this my wrapper object goes out of scope. And so automatically it's going to delete the memory allocated by load int data by calling destroy int data. And you don't have to do anything, okay? You don't have to explicitly free the memory, because once the object is garbage collected and it's deleted, it's going to call this the initializer for you, or finalizer for you. All right, and to make some tests, I create 3 wrappers. So we've got my wrapper 100, 200, 300, and then I print some values, value 1, value 2, value 3, to make sure that everything works. And as you can see, inside of here I call load int data, which should allocate some object, but I'm not explicitly deallocating anything anywhere. So let's see if this works. If I click on run and we wait, you can now see that inside of our Zig we had some info log here. So you can see Zig creating data from native code, creating data, which is the 3 constructor calls that we have here. And then I printed the values, value 1, value 2, value 3, and then when this main function goes out of scope, these objects are not used anymore, they're out of scope too. So Zig so Dart calls the delete function. So we have deleting data with value 100 in native code, which is this one, and then it deletes the one for 200 and deletes the one for 300, and then the program exited. So this is how you can work with native finalizers and in Dart, and this is really cool feature. I think this has opened a lot of doors to working with native code inside of Dart. And yeah, that'll be all for this video. Thank you guys for watching. Yeah, okay, there is one more thing. Okay, I talked about signing executables, and if you want to learn how to do that, then you can take a look at this link and you should be able to get started with that. Yeah, so thank you guys for watching. Please leave a like and subscribe, and if you want to watch more videos like this, yeah, thank you guys for watching. I'll see you guys in the next one. Bye.